Algebra 2, target 13. I can determine the end behavior of a polynomial function. So today what we're going to look at is what's happening to a function at the extremes. And when we say extremes, we mean very, very large values of x or very, very small values of x. And by small, we don't mean fractions. We mean negative 100 is considered a small number because it's to the far left of a number line. So yeah, that's end behavior. What's happening at the extremes as we get very, very large, which is positive infinity, you're going to see. Or we get very, very small, which we're going to denote as negative infinity. So we got a couple examples of some graphs. And what I want you to do when you see these graphs is kind of look what's happening on the very far right and the very far left. And look at the equations too and try and make some conclusions. So pause the video and take a look at these graphs and the equations and see if you can find some relationships between what's going on there. All right, so this first one, we have an x squared minus 10x plus 2. The right side is going up. We say the right side is going to positive infinity. Or we'd say as x goes to positive infinity, f of x is also going to positive infinity. The left side, as we see, that is doing the same thing. The left side is going to positive infinity. We don't say the left side. We'd say as x goes to negative infinity, f of x goes to infinity. And take a look at the lead coefficient there. This next problem, same thing. The right side is going to positive infinity, so as x goes to infinity, the function, the y value, is also going to go to infinity. However, the left side is going down. As x goes to negative infinity, the right side is going to negative infinity. And again, keep a look at your lead coefficient there. This third graph here, there's our lead coefficient. The right side, or as x goes to infinity, that's the right side, we'd say our function is going to negative infinity. You see the graph is pointing down. And then the left side, same thing. The left side, or as x is going to negative infinity, we're getting smaller values of x, our function is going to negative infinity. Again, keep your eye on the lead coefficient. This last one, our lead coefficient, is right there. The right side is going down, so as x goes to negative infinity, f of x is going to, I'm sorry, I said that wrong. As x goes to infinity, f of x is going to go to negative infinity. And our left side, as x is going to negative infinity, the left side, the smaller values of x, our function is going up, going to positive infinity. So take a look at those, look at the lead coefficients and see how it's related. So what we got there, as we look at our lead coefficient, there's two things you want to look at. You want to look at the degree. Okay, the degree is key. Then you want to look at the coefficient. All right? So when the degree is odd, take a look at the extremes here. When the degree is odd, your extremes will go in different directions. So the left side and the right side will do different things. If the degree is even, like a square, they're going to go in the same direction. If one side goes up, the other side goes up. Or if one side goes down, the other side goes down. And our lead coefficient determines what the right side is doing. Right? The lead coefficient, if it's positive, the right side will go up. If it's negative, the right side, or as x approaches infinity, will go down. Because you're multiplying by a negative number with a really large power. That's why the right side goes down when it's negative, and it goes up because you're multiplying by a positive number with a really large power. Now let's do some practice problems. Describe the degree and the lead coefficient of the polynomial function who's shown. Well, what is happening here? We can see both sides are going in the same direction. So that must mean we have an even power. Our lead coefficient is an even power, so it's an even degree. And our right side is going down. So that means it's a negative lead coefficient because our right side is going towards the negative numbers. Now there's some other stuff we can tell. We can see that there's a couple directional changes. You should know that's not going to be a square. So the power is at least 4. Usually you can count the directional changes to get what your power should at least be. There's 3 directional changes, so we should have at least 4 as our power or our degree. And take a look at this graph. What is going on here? Pause, write what you think, and we'll go over it. All right, so as we look at the right hand, it's going down. So that means our lead coefficient is negative. And the two sides are going in the opposite direction, so the degree is odd. All right? There's 3 different directions. There's a little shimmy in there, which leads me to think that there's probably degrees at least 5. But we know for a fact our degree is odd and the lead coefficient is negative. So, now we've looked at it graphically, let's look at it symbolically. Describe the end behavior here. What's happening? Again, we just want to look and we want to see, okay, take our lead coefficient, our leading term, and take a look. It is negative, so that means our right side is going to negative infinity. And our right side is described as x goes to positive infinity. So our lead coefficient is negative, so the right side is going to negative infinity. And our power is odd. So that means the left and the right are doing opposite things. Since the right side, positive infinity, is going to negative infinity, the left side will go the opposite way. So our function goes negative on the right, and our function goes negative on the right, and there's an odd power, the left will go to positive. All right, take a look here. Pause, try this one. Let's look at our leading term. Our lead term, this one's not in standard form, so we need to find our lead term by finding the highest power, and that's right there. We can see that the lead term is negative, or the coefficient is negative. So that means the right side, or as x approaches infinity, the right side goes to negative. So that's the function will approach negative infinity as x approaches positive infinity. And then the left side, since this is an even power, the left and the right will do the same thing. So since the left side went to negative infinity, so shall the left. So in review, to see your end behavior, there's a couple things you need to look at. You need to look at your powers and your coefficients. Look at your coefficients first. If your lead coefficient is negative, the right side goes to negative infinity. If your lead coefficient is positive, the right side goes to positive infinity. And once you know that, look at your power. If it's an odd power or an odd degree, extremes will go opposite ways. That means the right side will go up, left side goes down, or vice versa. If you have an even degree, the extremes will do the same thing.